Hello class, welcome to this video on the 4.5 practice on Canvas. So this lesson was about congruence for right triangles. Let's go ahead and get started. So which pair of triangles can be proven congruent using the hypotenuse leg theorem, otherwise known as the HL theorem? All right, so if we look at the part A, it says we have a couple right triangles. We have a hypotenuse. Remember, the hypotenuse is the longest side in a triangle, in a right triangle. And so we have hypotenuse, we have a leg, which corresponds, you got to be very careful to show that it corresponds to the other triangle, triangle in this case. So in this case, yes, this leg corresponds to this leg, because if you were to actually rotate this, right? If you were to take this side and rotate it 270, then you'll end up getting something like this. And so they do end up matching up if you were to rotate this counterclockwise 270 degrees. And so yes, so those legs definitely correspond, and then these hypotenuses correspond. So yeah, this can be proven congruent using the HL theorem. I guess you can check A. Now let's double check the other ones just to be safe. Well, we don't have a hypotenuse here, so that eliminates this. So no hypotenuse, right? Here, no hypotenuse. There's a hypotenuse here, but there's no leg, right? So therefore, the only answer can be A. All right, so question 2. For what values of A and B is the pair of triangles congruent by the HL theorem? Okay, so the HL theorem, if we're going to say that these are congruent, well, then that means that this is congruent to this, and this leg is congruent to this leg. Okay, and it has to correspond the right way, right? So like if I said that this was A plus 2, for instance, well, then this has to be A plus 2. It has to correspond, right? So if I were to take this triangle, and if I were to, say, rotate it this way, right? Or similarly, I can just take this and rotate it this way. Well, then I'll get a triangle that matches up with the description here, right? So yes, so then these sides do correspond. You want to be careful because some problems will say, well, it looks like it corresponds, but it doesn't actually correspond. So you want to make sure that when you kind of rotate it or whatever, that it does match up. So here we have the hypotenuses have to be equal to each other, right? Because they're congruent by HL. And so we can go ahead and set the hypotenuses equal. And we can also set the legs equal to each other here. So 3A plus B has to be equal to that. So let's go ahead and solve this first equation first. We want to subtract 7 on both sides. And we have 2A equals 8. Now we can divide 2 on both sides and get A is 4. So now we know A. We can plug A into the equation here and here. So we have 3 times 4 plus B equals 4 times 4 minus 3. 3 times 4 is 12. 4 times 4 is 16. Now 16 minus 3 is 13. So we have 12 plus B equals 13. So 12 plus what is 13? Pretty easy equation. B would have to be 1, right? If you were to use algebra, you would just subtract and you get 1. So B equals 1. So we got B is 1, A is 4. All right, question 3. We have another proof, or we've been doing a lot of proofs in the last couple of lessons. So question 3, it looks like we have what looks to be a rectangle, but we're not sure unless they give us the information here. So it says given that we have some right angles. Okay, so we are given that these are right angles. So N and Q are right angles. So that's given in the problem. Okay, we're also given that NO is congruent rather to PO. So we know that NO here is congruent to PO, or PQ rather, not PO, PQ. Okay, so, and that's also given in the problem here. So the reason for number 4 is that it's given. So we have 2 given statements kind of spread out throughout the proof. All right, so for number 2, triangle ONP and triangle PQO are what kind of triangles? Well, we know that these are right angles, and so these 2 triangles have to be right triangles, right? That's by the definition of right triangles. They have to be, right triangles based off of that definition. So they're right triangles because they have right angles. And then the reflexive property states that, well, because they share this side, that side is congruent to itself, right? And so OP is congruent to OP. Right? Remember when you're trying to prove something, that goes for that's always going to be the last statement that you write in a proof. And the reason that those are triangles, well, if you look at what we labeled here, we have a hypotenuse. Remember, the longest side is the hypotenuse, and the hypotenuse works for both of them. So this side that they share is the hypotenuse for both triangles, okay? So that's important to know, that the hypotenuses are the same for both triangles. So if this was the hypotenuse for one triangle, but not the hypotenuse for the other triangle, then we cannot apply this theorem. Okay, so in other words, what I'm saying is that if we were to split these 2 triangles, we would have something that looks like this, right? Here, and if we were to kind of split them apart, almost like if this were like a sandwich and you cut it diagonally, then that's how it would look like, right? And so these are the same, and they're both the hypotenuse. And then similarly, these are the same, and these are the legs. And so, and they're both right angles, so right triangles. And so they correspond to each other by HL theorem. They're congruent to each other. All right, question 4. So we're given that these are right angles, W and Y. So let's go and label that. W and Y are right angles. Vx is congruent to Zx. So we have Vx here is congruent to Zx. So they told us so. X is the midpoint. Okay, well, if X is the midpoint, well, that means that this side has to be congruent to this side, right? And so we got a lot of information from those statements. Okay, so this is a given statement. And notice that number 3, X is the midpoint, is also another given statement. So we got a couple given statements throughout. And we know that what we're trying to prove is going to be the last statement. So that we know that automatically that's going to be the case. Okay, so now let's go ahead and let's start with statement 2. So we know that they're right angles, so that's a given. And so therefore, because of that, because that's the case, okay, okay, so we know that these are right triangles because we have a right angle here, and the options are a little bit weird here. I think I might have made a mistake with one of the options here. So if you look here, there's nothing that really says that the triangles are congruent, right? So, or not congruent, that they're right angles, or that they're right triangles, okay? So we're going to just say that, well, these are right triangles. The answer for this problem in particular is that these 2 angles are congruent. So angle W is congruent to angle Y. And the reason is that the reason is not that they're right triangles. The reason is that all right angles are congruent. So there's something a little bit off about the problem. I think I messed up the reasoning. So just so that you know, the answer for number 2 is this, but the proof should really say something like this. The proof should really say something like, Because this is given, then we know that these two are right triangles. Like if we were to use the definition of a right triangle here, then we'd have had to say that these are right triangles. Okay, so, but just so you know, because they're right triangles, that would mean that the angles are congruent, which they are. So there's something a little off about this proof. I think it was just when I designed it. When we designed it, it was a little bit off. But in any case, those two angles have to be congruent because they're right angles, okay? And so for step 3, we said that was given. Step 4, the definition of the midpoint. So we said that because x is the midpoint, that means that those two are congruent. So wx is congruent to w or xy. And so that's our next statement. And apologize, there's another typo here. So it should be wx and xy or yx, right? Here it says yw, so this is incorrect. This should actually say yx. So if you're confused about that, apologize. That's what it should be. Wx is congruent to yx, based off of this diagram. Wx congruent to yx or xy. All right, and then 5. Triangles are congruent. Why are they congruent? Well, if we look at the information, we have a hypotenuse, we have that they're right angles, and we have a leg. And so by HL theorem, these triangles are congruent. Okay, moving on from that weird proof, with some typos there, apologize. Are the two right triangles congruent? Explain. So if we look at these two triangles, we have a right angle, which means, so that means we're going to use one of those theorems. We have a hypotenuse and nothing else. We don't have anything else about these triangles. I mean, aside from, well, yeah, aside from the angles. So, okay, so we have the hypotenuse, which is a side, right? So it's technically a side. We have an angle, and we have another angle. And so therefore we have angle, angle, side, angle, angle, side. And so yes, these triangles are congruent by angle, angle, side. Now next one, we have a side, which is the hypotenuse, the longest side. We have another side, and we have an angle. Now, when you look at this and it spells donkey, right? If it spells ASS or it spells SSA, well, that's not one of our theorems, right? So if it spells donkey or if it spells SSA, then that means that it's probably going to be an HL theorem, right? Because you're given a hypotenuse and a leg. Okay, so if you're given a hypotenuse and a leg, well, then that means, that it's probably going to be the HL theorem. But you also have to make sure that these two triangles, that these two sides are actually corresponding. Do they correspond to each other? And the answer is yes. So if I were to rotate this way, then this triangle would look like this, right? And then if I were to reflect it, it would look like this. So yes, those two sides correspond to each other. I want you to try to visualize that because you're going to need to know in the future whether two sides correspond to each other correctly, okay? And so yes, these two correspond to each other. And so yes, they are congruent and by the HL theorem. All right, select all the true statements for the figure shown. So we have two triangles, one right triangle, and then another triangle that we are not sure if it's congruent or not, or if it's a right triangle, I mean. So we're not sure if we have a right angle here. So we're going to look at the statements to see if they're true. if measure of angle D plus measure of angle E is 90, then the measure of angle F is 90. Let's see if that's true. Well, suppose D is 30, and suppose E is 60. Well, then we know that 30 plus 60 is 90, right? So there you go. So if they're equal to 90 when you add them, what does that mean about angle F? Is angle F 90? Answer is yes, because remember that by the triangle angle sum theorem, all the angles add up to 90 or to 180. And so if I have 30 and 60, well, that's 90. And then if I add that to 90, that's going to give me 180. And we already said that this was angle D and angle E combined. And so that means that angle F has to be 90 degrees so that it adds up to 180. So here's the point. If you have two angles in a right triangle that add up to 90, that means that the other angle has to be a 90-degree angle. Okay, so this part right now, so far, is true. So if that's the case, then angle F is 90. All right, well, so angle F is 90. Now we know it's a 90-degree angle based off of this statement. The triangles are congruent by HL theorem. So now let's see if that's true. So we have a hypotenuse now, right? And we have a leg. We have a hypotenuse now, and we have, in this case, a leg. Now are these two legs the same? And the answer is yes. If I were to rotate this triangle, then like this way, I'm going to get something that looks like. I'm gonna make these try to line up as best as I can. And so if I were to rotate that, I would get something that kind of looks like this. This would be going downward like this. This side would be rotating. So I would get something like this, right? If I were to rotate this a little bit. And then if I reflect it this way, and then reflect it the other way, I get this exact same right triangle. Okay, so yes, those two angles correspond because you can find a transformation to get them to overlap. And so therefore, they have to be congruent. Okay, the reason I'm being very specific about this is because you want to make sure that those are actually the same side. All right, so yes, the triangles are congruent by the HL theorem. Let's look at the next. Let's erase what we know now here, because now we're done with example or part A. Part B, if D is 37, that means that A is 37. Is that true? No, that's not true. That's not true in general. If this is 37, there's no way that we can say that this is 37 just from that statement alone, okay? A could just as easily be 40. These angles are not tied to each other. So that's not going to be true. All right? It's true if we have some more information, but right now that's all the information we have. So based off of that, that's not going to be true. All right, if angle E is congruent to angle B, then the triangles are congruent by SAS. Let's look at that. So if angle E is congruent to angle B, well then they're congruent by SAS. And let's see if that's true. Well, we have a side, which is the hypotenuse. We have the angle, and we have a side. That is true. Those correspond to each other. So yes, C is true. If angle F is a right angle, then the triangles are congruent by the HL congruence criterion. Yes, kind of like part A. If that's a right angle, then we have HL, HL, and so those are congruent. If D and E is equal to 90, then F is equal to 90. That's true. We talked about that. If they add up to 90, then that means that this has to be a 90-degree angle. So that's true. The triangles are congruent by the SSA triangle congruence criterion. That's false. Remember that they can't be congruent by SSA. They can be congruent by HL, not SSA. right, so let's look at question 8. So Muhammad wrote the paragraph proof to show that triangle DEG is congruent to triangle EFG. What mistake did he make? So we have, okay, so he says triangle DEG and EFG are right triangles. Okay, that's true. They're right triangles. They have a right angle, the definition of right triangles. Figure shows that line segment DE is congruent to line segment EF. That's true. Those are congruent based off of the tick marks that we see here. And it says, and EG is congruent to EG by the reflexive property. That's true. EG is congruent to EG by the reflexive property. Therefore, by the HL theorem, triangle DEG is congruent to triangle EFG. There is the issue right there. Those two triangles are not congruent by HL theorem. How do we know that? Well, because if you look at this, we know that this right here is the hypotenuse for this triangle, triangle 1. So if we were to draw that triangle, that's the hypotenuse for that triangle, right? So this is the hypotenuse. However, for triangle 2, if we were to draw it, these two are congruent. These two sides are congruent, but this is not the hypotenuse of triangle 2. The hypotenuse of triangle 2 is this side. This is the hypotenuse for triangle 2. And so the hypotenuse of triangle 1 does not correspond to the hypotenuse for triangle 2. So you cannot claim HL theorem. This is what I was saying about potential sources of error. You have to make sure that the side that you have corresponds to the correct side when you're doing the theorem. So you can't use a hypotenuse leg theorem because the second triangle does not have a hypotenuse that's congruent to the hypotenuse of the other triangle. They do not correspond. Okay, so his error here is that in triangle EFG, EG, let's see here. Yeah, so in triangle EFG, EG is a leg. So in here, this is a leg, whereas in the other guy, it's a hypotenuse. So they cannot be corresponding sides. All right, question 9. Is there enough information to determine whether the two triangles are congruent? If so, write the congruent statement. So, okay, so let's look at these. We have a hypotenuse, we have a leg. Well, do we even have a hypotenuse? The answer is no. We don't know that this is a hypotenuse. We know that it's a side. We know that this is a side, but we do not know that it's a hypotenuse. Why? Because we don't know that this is a right triangle. We can't assume that this is a right triangle. We don't know what this angle is. It could be 89.5 for all we know, where it looks like a right angle, but it's slightly less than a right angle. We're not sure. We have to know, we have to be given the information, or we have to figure it out by some other means, right? But there is no more information to figure this out. So we don't know that those are right angles. If we did, we can claim HL theorem. So there's not enough information to determine that they're congruent. Question 10. For what values of x and y are the triangles congruent by HL? So this is similar to one of the other questions we did. So since these are both right triangles, so this is a hypotenuse, and that's congruent to this. This is a leg, and that's congruent to, is that really congruent to this? Well, yes, it's congruent to this guy. If you were to rotate it and reflect it and everything, it will work out. Okay, so basically we have two equations here. We have leg is equal to leg, and then we have the hypotenuse is equal to hypotenuse. All right, so let's go ahead. So now we know that x is y plus 2, right? So what we're going to do is we're going to replace x with y plus 2 in this equation. So this is known as a substitution property because we're replacing x with y plus 2. So we have 3y equals, x is now replaced with y plus 2. And then we have plus 4, of course, off to the side. And then 2 plus 4 is 6. So we have 3y equals y plus 6. We'll go ahead and subtract y on both sides. 3y minus 1y is 2y. So we got 2y equals 6. Divide by 2 on both sides. So y is going to be 3. So we got y. Now because we have y, that means we have x. So we have x equals 3 plus 2. And so x equals 5. So we got 5 and 3. All right, so now we're gonna finish off the problem set with the Pythagorean theorem. So use the Pythagorean theorem to find the missing side. So we have here, we want to figure out this third side. Then we're gonna need to use Pythagorean theorem because it's a right triangle. Remember the Pythagorean theorem is a squared plus b squared equals c squared. And c is always the hypotenuse, okay? Hypotenuse is always the longest side, and that's going to be given by c. All right, so let's suppose that that's a, and the missing side is b, okay? So if it doesn't matter which one's a, which one's b, but we'll just call the side that we have a. So we have 8 squared plus b squared, we'll call this b, equals c squared. The longest side is c, so it's going to be 17 squared. All right, so now we got 8 squared plus b squared equals 17 squared. 8 squared is 8 times 8, 64. And then we got 17 squared. So on the calculator, you do 17 times 17. Should be 269, 289. Okay, somewhere around there. Okay, so 289. Subtract 64 on both sides. So we get b squared equals, subtract those, you get 225. And then remember to get rid of the squared here, you do the square root of both sides. And so now the square and the square root cancel, which is how you get left with b by itself. So b is equal to the square root of 225, which is, on the calculator, is 15. So we got our missing side. So the missing side is 15. The two triangles are congruent by, in this case, if we know that this side is 15, if we know that missing side is 15, then we can go ahead and safely say that these two triangles are definitely congruent. They're congruent by side, 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 or they're congruent by side, angle, side, side, angle, side. So whichever drop down you have, you choose either one of those. I'm not sure which one it is, but it's either one of those. All right, guys, that's it for the video. I hope you found this useful, and as usual, I'll see you in the next one.